Hello guys, welcome to Recrystallization Lab. You might be surprised by watching rock candy and sugar crystal picture on the first slide, but you will understand as I move further. Recrystallization is very commonly used technique in industry. Pure sugar, salt are obtained through recrystallization, and this is done by dissolving the sugar in water and then heating the solution, after which it is made to cool down slowly at a room temperature, and as it cools, it begins to form a crystal of pure sugar. Laboratory recrystallization can be used to purify substances and can be combined with advanced imaging techniques to understand the nature of substance. So let's understand crystallization theory step by step. So the crude solid is made up of desired compound and impurities, and they all need to get dissolved in hot solvent. So when solvent cooled, the pure compound is crystallizes as a solid and the impurities leaving behind in solution. Filtration collects the desired solid from liquid and the impurities dissolve in the solvent. So the solvent is chosen so that the desired compound is soluble when it's hot and insoluble when it's cold. We use this technique to purify organic solids based on the solubility of solids increasing with increased temperature. So we will take 2 days to complete this experiment, and your today's goal is to learn how to purify a solid organic compound using the recrystallization technique. So in this technique, use the solvent in which the solute is soluble when it's hot but insoluble when it's cold. Dissolve the solute in minimum volume of boiling solvent. Allow it to cool slowly to room temperature and then put it in ice bath. Use vacuum filter for filtration and wash the purified product with small amount of cold solvent. Determine mass and melting point to assess yield and purity. Also take melting point of impure solute. So here are your today's tasks. So in part 1, you will be using the proper technique to recrystallize sulfanilamide using 95% of ethanol as a solvent. For the proper technique, we want to dissolve all the sample in minimum volume of boiling solvent and allow it to cool slowly to room temperature and then put it in an ice bath. You will collect the crystal using vacuum filtration. In the part 2, you will repeat the recrystallization with modification to the procedure. There are 3 variations to taste and you will be assigned one of them. The other 2 variations will be performed by your virtual lab partners. So the idea here is that in each variation, there is a mistake being performed on purpose. So you can see how this mistake affects the results. Each mistake can affect either the percentage recovery that is measured by the masses or the purity itself that is measured by melting point. So this time you are doing your lab virtually, but these are some tips which will be very useful when you are doing your experiment in actual lab setup. So first tip regarding the solvent is keep it hot but not too hot. So keep the solvent right around the boiling point of the solvent. So don't remove from heat and walk around, but don't even boil violently either. Work quickly, so add solvent faster than it evaporates. Don't add too much solvent. Once the solid dissolves, stop there. Dissolve it all. So make sure all the solid get dissolved. So cloudiness means solid is still there. When filtering, rinse with ice cold solvent. So your compound is soluble in warm solvent, so use ice cold solvent. Let's go over to your pre-lab question now. So the first question you are asked to calculate how much 95% of ethanol will be required to dissolve 0.75 gram of sulfanilamide at 78 degrees Celsius. So the reason for making this calculation is that you will know ahead of time that approximately how much hot solvent you will be adding. So the solubility at 78 degrees Celsius is around 200 milligram per ml. So the calculation is simple, just that you have to take care that here it's a gram and it's milligram, so you need to convert it. So the second question, using the volume calculated in question 1, calculate how much sulfanilamide will remain dissolved in mother liquid after the mixture is cooled at 0 degree. So this is the calculation, and you will expecting to lose at least 5% of your original mass in this technique. So this is the solution. So about percentage recovery. So generally at the end of any chemical reaction, you are expected to calculate the percentage yield. But this is not a chemical reaction. Recrystallization is a technique to purify your product. So in recrystallization, you are expected to calculate the percentage recovery, not the percentage yield. So calculate the percentage recovery using the equation and assess the efficiency of your purification technique. The pure product is the sample after recrystallization, and the crude product is the improved sample before the recrystallization. On the next page, you will be watching the more video to learn more about the recrystallization, and after that, you will perform your today's experiment.